So very well, carbohydrates, and the simplest carbohydrate which you are told is blood sugar glucose, where naturally counting from carbon 1, 2, 3, 4, 5, 6, we'll find that carbon 3, this OH is to the left, all of them are right. Now naturally this OH, which is the highest numbered chiral carbon having OH to the right, we call it capital D glucose. It's also Levy rotatory, it's also dextrorotatory, but that dextro has nothing to do with capital D. I guess you understand that. This the capital D is about this OH to the right. Yes or no?
Yes, sir.
And C3 to C5, C3 to C5, C3 to C5, C3 to C5 is identical in this P2 hexose, which you know is fructose. This fructose is also capital D fructose, yet again because this OH is to the right. This is dextrorotatory plus 52.7 degree. This is Levy rotatory minus 92.4 degree. And right away, when it comes to fructose, you understand? When it comes to fructose, you understand? The capital D could well be Levy rotatory. Capital D could well be Levy rotatory. Yes or no? बच्चे लोग हाँ ना बोलो.
Yes, sir.
From the Fisher projection, we want to migrate to the Haworth projection, which is the range form, where I tell you at carbon 1, it's anomeric, this OH below, and naturally below in the sense anti to CH2OH, this carbon anti to CH2OH, carbon 5 पर जो CH2OH होता है इसके anti होने से this is alpha glucopyranose, and then this is beta glucopyranose, which is OH is syn to CH2OH. Please keep responding.
Yes, sir.
कार्बन 6 का CH2OH पर अगर ये सिन होगा तो ये बीटा होगा. Beta form is more stable because I tell you in the video class, because in the beta form you'll have this OH equatorial, you'll have this axial. So I'm not going there. I have related these two forms with the chair forms. I've told you why beta form is more stable. These are anomers which are differing only at one carbon. Naturally, this carbon 1 anomeric carbon is when OH anti to CH2OH is called alpha glucopyranose, and the two stay in equilibrium with the open chain. There are some reactions which are not given by glucose as an aldehyde because in this hemiacetal form, it's hemiacetal. OH in the hemiacetal form, that CH2 is not available. So you know about some reactions which are given by glucose, some reactions which are not given by glucose. So with this alpha glucopyranose and beta glucopyranose understood, let me do the same for fructose. Now the only change this time is, see, if I believe that 3, 4, 5 is identical in glucose and fructose, I would want this to be 3, 4, and 5. And again at 5, this CH2OH above would be the benchmark. This is carbon 4, which will be below. This is carbon 3, which is above. And it's anomeric at carbon 2. It's anomeric at carbon 2. So this time OH below, and you'll call it alpha fructofuranose. You know it's called furanose because it's a 5-membered ring. And this above, this below will mean it's alpha. It's going to be anomeric at carbon 2. Because यहाँ पर क्या होता था, यहाँ पर ये lone pair जाकर के अटैक करता था carbon 1 पर. This was carbon 1, becoming anomeric. Whereas here this lone pair would go to carbon 2. And naturally it will be a 5-membered ring then. 1, 2, 3, 4, 5-membered ring. At carbon 2, you'll have the anomeric property. And naturally, at carbon 2, तो 4 में वैसे ही बता रहा हूँ जैसे 4 में इसका रखा हुआ, 3 में वैसे ही बना रहा हूँ बिकॉज 3 में इसका ऐसा रखा हूँ. 3, 4, 5 सेम होता है ग्लूकोज और फ्रक्टोज का. और ये CH2OH के रिस्पेक्ट में अगर कार्बन 2 पर ये OH अबव है, then I'll want to call it beta. I'll want to call it beta fructofuranose. बच्चे लोग हाँ ना बोलो.
हाँ सर.
I think this part is understood. Carbon 1 is anomeric for glucose, carbon 2 is anomeric for fructose. Alpha when OH and CH2OH at carbon 5, they are anti. Beta when the two are syn. Same for fructose as well. If they are anti, it's called alpha. If they're syn, they're called beta. I think all these names and the structure of the corresponding rings is being understood. Will want to respond with a yes or no for me to move forward?
Yeah.
If you've seen all the video classes, I don't think you'll want to copy anything. You'll just want to have a look. I'll give you a minute to look at these structures, and right away, I would move to sucrose. Right away, I would move to sucrose. I think the structure of the disaccharides were there in the video classes as well. Have you noted them down?
Yes, sir.
So with the alpha and beta nomenclature understood, we'll want to talk about how alpha glucopyranose and beta fructofuranose would fuse at the respective anomeric carbons. You know, sucrose with water giving you glucose plus fructose. Sucrose with water giving you glucose plus fructose. Sucrose, C12H20O, C12H22O11 giving you glucose plus fructose. Do you understand why it's called inversion of sugar? I think you understand that part.
Yes, sir.
Yes, sir.
This is more levorotatory than dextrorotatory, so naturally, eventually, a solution which was dextrorotatory will become a mixture of dextrolevio, this being more levio. The overall process will be called inversion of sugar. The overall process is called inversion of sugar, and for that reason, the enzyme is called invertase. You know, invertase is going to be a mixture of alpha glucopyranoside and beta fructofuranocide, and this being absolutely non-reducing, and no mutarotation and no osazones formation would mean all of this would mean that there is no hemiacetal. And if there is no hemiacetal, you'll want to bring the two anomeric carbons, to each other and remove hemiacetal at both the ends. I'll always choose this as carbon 1, I'll always choose it as carbon 2. क्योंकि मेरे को कार्बन 1 और कार्बन 2 दोनों पे इसका और इसका हेमियास्टल खत्म करना है, OR बनाना है, so that it's completely non-reducing in nature. The places left empty are obviously occupied by hydrogen. मैं hydrogen draw नहीं कर रहा हूँ. We'll want to move in a faster pace because I've given you the video classes of all of this. CH2 ऊपर है, यहाँ पर नीचे मतलब naturally alpha glucoside और इसको बीटा फ्रुक्टोसाइड करने के लिए मेरे को ये 5 नंबर पर जो CH2 है उसको नीचे रखना पड़ेगा, और इसको नीचे रखूंगा तो नेचुरली 3 और 4 का कंफिगरेशन भी चेंज हो जाएगा. ये ऊपर था तो ये नीचे था, ये ऊपर था तो वो ऊपर था, तो अगर ये नीचे है तो नेचुरली 3 नंबर वाला OH भी नीचे हो जाएगा एंड 4 नंबर वाला OH ऊपर हो जाएगा. आई थिंक यू आर गेटिंग मी. Alpha glucosidic, because this bond is anti to CH2OH out here. This carbon 6 CH2OH is the benchmark every time. Anomeric पर ये इसके anti होगा तो ये alpha है, alpha glucosidic, और यहाँ पर this being the benchmark, ये अगर इसके sin है तो ये beta है, beta fructosidic, alpha glucosidic. Beta fructosidic is the enzyme which is going to work here, and sucrose is going to be a non-reducing sugar, which will mean इवेंचुअली व्हाट हैपेंस, ये हम लोग वाटर डाल के निकालते हैं, पर होता क्या है, ग्लूकोज और फ्रुक्टोज में से वाटर निकलता है और सुक्रोज बनता है. ऑल दी मोनोसैकेराइड इनिशियली फॉर्म would merge together to form disaccharide and trisaccharide and polysaccharide and polysaccharide. Please respond with a yes or no. You don't need to draw structures. I think you have drawn them by now. If there is a doubt, you'll want to ask me. Otherwise, you'll want to move at a faster pace. Alpha glucosidic, beta fructosidic. Yes or no?
Yes, sir.
The next structure which I tell you is maltose. The next structure which I tell you is maltose. Allow me to remove this clutter. करेगा बेटा?
Yes, sir.
इसके रेस्पेक्ट में अल्फा ग्लूकोसाइडिक है, इसके रेस्पेक्ट में बीटा फ्रुक्टोसाइडिक है. मैल्टोज में वाटर डालने से you get glucose plus glucose, 2D plus glucose. And this maltose happens to be a reducing sugar. This happens to be a reducing sugar which gives monophenylosazone. And monophenylosazone would mean there is one hemiacetal, which is obviously making it look reducing and giving you the osazone. And naturally there will be one acetal. The bond linkage is C1C4 linkage. The bond linkage is C1C4 linkage. बच्चे लोग हाँ ना बोलो.
हाँ सर.
और जो एंजाइम लगता है वो अल्फा ग्लूकोसाइडिक लगता है. तो मेरे को C1C4 लिंकेज एस्टैब्लिश करना है, और बिकॉज एंजाइम अल्फा ग्लूकोसाइडेज लगता है, I want to have this alpha. So this alpha glucoside at carbon 1. Now alpha would mean at carbon 5, as usual, I want to have this CH2OH above, this is below. This OH below, this OH above, and this OH below is carbon 2, 3, and 4. And this would be added to carbon 4. देखो इसका carbon 4 से लगाऊंगा, अब ये OH का ओरिएंटेशन नीचे, तो इसको मैं नीचे रखता हूँ. बच्चे लोग हाँ ना बोलो.
हाँ सर.
अब एनसीईआरटी के हिसाब से ना ये अल्फा ग्लूकोसाइडिक बॉन्ड है, अल्फा तो यहीं पर होता है, ये तो ओपन अप और बंद होता है. मैं इसको कर्वी में बताता हूँ, बट इफ यू गो बाय एनसीईआरटी लैंग्वेज, यहाँ पर इसको अल्फा दिखाना तो ये मैं ओएस को नीचे रख दूंगा, और जो यहाँ पर म्यूटर रोटेशन होगा, ये खुलेगा बंद होगा, तो ये नीचे भी रहेगा ऊपर भी रहेगा. बट दिस इज हाउ इट्स रिप्रेजेंटेड इन एनसीईआरटी. दिस इज acetal, दैट इज हेमियासिटल. OR, ये OR OH, ये हेमियासिटल है, ये खुल सकता है, यहाँ पर फ्री CHO मिलेगा, इसलिए यहाँ पर रिड्यूसिंग होगा, और एक फिनाइल मोनोफिनाइल मिलेगा. अल्फा ग्लूकोसिड. यस और नो? ठीक है बच्चे लोग.
यस सर.
तीसरा स्ट्रक्चर मैं जो बताता हूँ सेल्यूबियोस का बताता हूँ. जो तीसरा स्ट्रक्चर मैं बताता हूँ सेल्यूबियोस, ऑल्दो एनसीईआरटी में नहीं दिया हुआ है, बट एक पॉपुलर डाइसेक्राइड है. सेल्यूबियोस भी दो ग्लूकोज नहीं देगा, रिड्यूसिंग होगा, मोनोफिनाइल होगा, एक हेमियासिटल, एक acetal. द ओनली डिफरेंस इज यहाँ पर C1C4 लिंकेज वुड बी बाय बीटा ग्लूकोसाइडेज एंजाइम. Enzymes are the most specific catalyst. So enzyme beta glucosidase would mean the bond here is beta glucosidase. Yes or no? It would mean the bond here is beta glucosidase. Got me?
Yes sir.
So everything else remaining the same. अगर मेरे को इसको बीटा बनाना है, तो naturally ये anomeric कार्बन हो गया, I would want to make the 6-member ring like this. एंड ये मैं ऊपर की तरफ बना रहा हूँ, जिससे इसको मैं बीटा ग्लूकोसाइड बोल सकता हूँ. ये ऊपर की तरफ है और ये CH2OH भी ऊपर है. With respect to this carbon 5 का 6 वाला CH2OH, I would want to make it same. Everything else remaining the same. खाली जगह जो होगा वो naturally taken up by hydrogen. तो ये बीटा ग्लूकोसाइड दिख रहा है. बच्चे लोग हाँ ना बोलो.
हाँ सर।
तो समझ में आ रहा है ना ये OR है, वो OR OH है, ये कर्वीलिनियर रहेगा, खुलता रहेगा, बंद रहता रहेगा। अगर मान लो इसको हम लोग बीटा ही दिखा दे, इसको ऊपर दिखा दे, वो उतना फर्क नहीं पड़ता है। बच्चे लोग हाँ ना बोलो। सिर्फ सुक्रोज जो नॉन रिड्यूसिंग था, मेरे को दोनों का एनोमरिक कार्बन खत्म करना था, तो मैं दोनों का हेमी ऑक्सीडेट को खत्म करने के लिए दोनों का एनोमरिक कार्बन लिया, वरना C1C4 लिंकेज होता है, मेरे को पता है C1C4 लिंकेज ज्यादा कॉमन होता है। इसके बाद नेक्स्ट स्ट्रक्चर है लैक्टोज मिल्क शुगर, वहां पर भी C1C4 लिंकेज होता है, वहां पर भी C1C4 लिंकेज होता है। द ओनली डिफरेंस इज आई कैन रिमूव दिस क्लटर, कॉपी नहीं कर रहा है, ये सब किया हुआ है तुम लोग का। बच्चे लोग हाँ ना बोलो।
हाँ सर।
द नेक्स्ट स्ट्रक्चर इज लैक्टोज। प्लीज गो अहेड, टेल मी व्हाट इज लैक्टोज मेड अप ऑफ।
सर बीटा गैलेक्टोज एंड बीटा ग्लूकोज।
बीटा गैलेक्टोज एंड बीटा ग्लूकोज। तो ग्लूकोज और गैलेक्टोज होता है, यहाँ पर ग्लूकोज और गैलेक्टोज होता है। मैं जान करके पहले गैलेक्टोज प्लस ग्लूकोज लिख रहा हूँ, मैं जान करके पहले गैलेक्टोज और उसके बाद ग्लूकोज लिख रहा हूँ। आई होप यू अंडरस्टैंड व्हाई एम आई डूइंग दिस, बिकॉज यहाँ पर the glycosidic bond will be galactosidic bond, it will be galactosidic bond, it will be galactosidic bond, the bond here will be galactosidic bond। यहाँ पर जो bond होगा वो बीटा galactosidic bond होगा। So you know, if this is beta galactosidic, if this is beta galactosidic, one thing which I have told you in the again video classes before, that glucose and galactose will differ only at carbon 4। तो ये कार्बन 2 है, ये कार्बन 3 है, ये कार्बन 4 है। ग्लूकोज और गैलेक्टोज C4 एपिमर्स था, तो इसको ग्लूकोसिडिक से गैलेक्टोसिडिक बनाने के लिए सिर्फ 4 नंबर का जो OH नीचे में था उसको ऊपर कर देंगे। बच्चे लोग हाँ ना बोलो।
हाँ सर।
तो यहाँ पर मेरे वीडियो क्लासेस में था, यहाँ पर मेरे वीडियो क्लासेस में था मोनोसैकराइड्स में एक एक्स्ट्रा ही बता दिया हूँ, सेलुलोज। After this, naturally we'll want to open up polysaccharides, and I saw there are a lot of questions from polysaccharides directly from the information that is given in NCERT. So let's start polysaccharides. I'll want to remove this entire clutter and I'll give you some information which is absolutely NCERT based. Can I rub it off?
Yes sir.
Now among polysaccharides, which are naturally monosaccharides bonded by glycosidic bonds, which would be the natural abundant, this will be the natural abundant form of carbohydrate, and would largely provide two things, which is they would naturally be food and they would be structural in nature. Wood is also a polysaccharide, cellulose, you know. Starch is the food which is stored in plant kingdom, and you know, is the food, the dietary carbohydrate, which is keeping or feeding the entire planet. ये सारा कॉपी करना, you want to start copying down. You start with starch, which is the most common polysaccharide. I hope the board is visible.
Yes sir.
So it's the main storage polysaccharide in plants. Photosynthesis में they prepare glucose, but the stored form is starch. Naturally, it's the most important. It's the most important dietary source. I would be point-wise writing, you know, stuff from NCERT. I'm going to point by write everything which is there in NCRT, found in cereals, tubers, vegetables, roots, now it's made up of D-glucose. It's made up of D-glucose and have two components which are one amylose and two amylopectin. I hope you are noting it down. I hope it's pretty readable.
Yes, sir.
So the two popular components of starch are amylose and amylopectin. I'm going to talk about the two one by one. I hope you are hearing me loud and clear. Please note it down. I want to move at your pace. Please let me know once you have copied it down. Please tell me once you're done. You want to talk about amylose now?
Yes, sir. Done.
So if I begin with amylose, it's the water soluble component which accounts for 10 to 15% of starch. Let me check. In NCRT, it's given 15 to 20%. It's composed of 200 to 1000 alpha D glucose units. So it's supposed to be long, unbranched chain made of 200 to 1000 alpha D glucose via C1C4 linkage. So it's long unbranched chain having 200 to 1000 units which are bonded via C1C4 linkage. And the picture I want to draw right away is if this is alpha and this is carbon 4, then this is again alpha and this is carbon 4, and this is how it's supposed to be polymeric in nature. Above, below would mean it's alpha. Above, below would mean it's alpha. C1, C4, C1, C4, and naturally it's polymeric in nature. It's alpha glucosidase, be it this or this. अल्फा ये ऊपर है नीचे, ये ऊपर है नीचे, अल्फा ग्लूकोसिड। बच्चे लोग हाँ बोलो।
हाँ सर।
I hope you're noting it down. We won't talk about amylopectin. Please let me know once you're done.
Yes sir, done.
Now, amylopectin is supposed to be the water insoluble component. It's supposed to be the water insoluble component, which is going to account for 80 to 85%, 80 to 85% of charge. It's supposed to be a branched chain form. It's supposed to be a branched chain form. Made of linear C1, C4 linkage of alpha D glucose, like you had in amylose. And the branching is using C1, C6 linkage. So once you have copied it, I want to explain it to you. It's called the branched chain isomer or the branched chain form polymer made of linear C1, C4 chain link, and the branching is using C1, C6 linkage. So I've told you about amylopectin. I'm going to retain this structure of amylose here, and I'm going to draw the structure of amylopectin on top. So this is amylose, this is amylose, this is amylose. And now I draw for amylopectin. Amylopectin, again the way it's drawn in NCERT and the way it's supposed to be, would be very much like amylose. You know, C1, C4 linkage, C1, C4 linkage. This is alpha between C1, C4. But चलो हाँ ना बोलो।
हाँ सर।
और फिर C6 जो है ना, C6 से ब्रांचिंग होगा, C6 से ब्रांचिंग होगा। ये भी अल्फा है, नेचुरली ये भी अल्फा है, ठीक है, ये भी अल्फा है, पर जो ब्रांचिंग होगा ना वो C1 C6 की वजह से होगा, C1 C6 की वजह से होगा। तो C6 कार्बन ये होता है CH2OH, यहाँ से OH निकालोगे तो ऐसा बनेगा, ये सो नो। ये जो लीनियर ये अल्फा अल्फा है, जो लीनियर है वो अल्फा अल्फा है, जो लीनियर है वो अल्फा अल्फा है। यू गेटिंग मी?
Yes sir.
Naturally, यहाँ पर O के बाद भी I can say it's polymeric. Here भी O के बाद I say it's polymeric. Here again I can say it's polymeric. तो जो ब्रांचिंग आ रही है, ब्रांचिंग C1 C6 की वजह से है. ये C6 का हो सकता है, फिर किसी के साथ जो ब्रांचिंग हो जाए. So it's going to be branched that way. Linear nature भी है, branch nature भी है. Linear is because of C1 C4 linkage. C1 C4 linkage, and the branching is by C1 C6. This is amylose. Naturally, this one is amylopectin. I hope you are understanding me. The linear form is because of the change form is because of C1 C4 linkage, and the branching is because of C1 C6 linkage. We will want to move on. बच्चे लोग हाँ ना बोलो.
हाँ सर.
Can I remove this clutter?
Yes sir.
People online would want to respond and pinpointing the information which is there in NCERT. You'll find questions requiring the same. Can I remove this clutter?
Yes sir.
All these polymers where you find one end is getting going to be free. कितना ही बड़ा चेन होगा, लास्ट में एक एंड तो फ्री होगा. अब एक एंड जो फ्री होगा वहां पर हेमी आर्टिकल रहेगा, वो लगेगा क्यों, इट विल ओपन अप. But all these polymers, amylose or amylopectin, or if I'm going to talk about cellulose now, the amount of the reducing portion would be so small. Out of 1,000 units, if you have one unit which is opening up and giving you CCHO, they're all practically considered non-reducing. They're all practically considered non-reducing. It's a piece of information you'll want to take home. NCERT में नहीं लिखा है, but you'll want to know that eventually they're all taken non-reducing. I think you're understanding me. इतना बड़ा चेन में एक जगह से CHO कहीं भी खुलेगा, तो उसको हम लोग प्रैक्टिकली नॉन रिड्यूसिंग बोलते हैं. टॉयलेट के साथ में बोलते हैं ऑलमोस्ट नेगेटिव टेस्ट ही आता है. लेट्स टॉक अबाउट सेल्यूलोज. Now this occurs exclusively in plants. It occurs exclusively in plants, and naturally is the most abundant organic substance. Is the most abundant organic substance in plant kingdom. It's the principal component of cell wall in plant cell, and it is basically a straight chain. It's an unbranched chain made up of beta D glucose with C1C4 linkage. Unbranched straight chain made up of beta glucose with C1C4 linkage. And in that case, then definitely it's going to look like the following. See, I got to I got to make it move up. I got to make it move up. Yes or no? Because I need this to be beta. I need this to be beta. I need this to be beta. Beta with respect to the CS2 over here. Linkages C1C4. Linkages C1C4. चलो खाना बोलो. Please let me know once you are done copying down.
Yes, sir. We'll talk about the last one, which is glycogen. Hello. बोलिए ना बोलिए. हाँ क्लास में बोलिए ना बात.
So we'll talk about the last one, which is glycogen. I hope I can remove this letter.
Yes, sir.
I did tell you I'm limiting it pinpoint to the information which is NCRT. I'm quoting NCRT everywhere. Glycogen, is the carbohydrate stored in animal body. So basically, it's the carbohydrate. It's basically the carbohydrate stored in animal body. Then it's also known as animal starch. It is also known as animal starch. It is also known as animal starch because its structure is similar to amylopectin. Although it's more highly branched than amylopectin. It's going to be stored in brain, muscles, and liver. And every time when body needs glucose, a student of biology would know better. Glycogen is broken down to glucose. So you want to take down these points because these are exactly given in this manner in NCRT. It's also found in yeast and fungi. Is the last piece of information I find in NCRT. It's also found in yeast and fungi. Please note it down and let me know if you have any doubts so far. We can move on.
Yes, sir.
We can move on. And there is a small segment which is importance of carbohydrates during NCRT. There is a small segment which is importance of carbohydrates during NCRT. And naturally, the importance of carbohydrates has to be it provides food and also is the structural unit in the sense this is the principal form of food. This is the principal form of food. So it's essential for life. This is essential for life in both plant and animal kingdom. Naturally, this is principal food. Sugar. Honey is used as an instant form of energy. Food provides you energy, and it's also going to have medicinal values. Then it's going to be of storage purpose, cellulose in plants and glycogen in animals. And So it's basically the reserve food. This is basically the reserve food or a form of reserved energy. And it will be the structural unit. It will be the structural unit in both living non-living worlds. So it will be like wood or cotton in the form of cellulose or ribose, deoxyribose, forming the nucleic acids. So I would do a little bit of DNA and RNA. I would do a little bit of DNA RNA a little later. I've done amino acids with you. So just have a pinpoint information about these facts which are there in NCERT. You'll want to just jot them down in your notebook. And as far as today's class is concerned, the population being a little thin, guess most of the students have school today. We'll do problem solving in the live class. We'll do problem solving in the live class. Quickly tell me if you have a doubt here or there. As I told you, I hope I've given you the set of questions. I'll want to do problem solving in the live class, or at a time when everyone can attend it. So before I let you go, Devansh, Gaurav, Kavyansh, Soham, anything you want me to repeat? Along with the information I gave you today, you'll want to be upbeat and updated with everything which was there in the introductory video classes. Make notes properly, revise them properly, and at the next opportunity, we'll be solving questions from the JME's exams. So this much for the time being. Stay happy, stay healthy. See people soon. Okay.
Yes, sir.
Bye bye.
Bye, sir.